Over to you, Dr. Prithvi. He's going to talk about 3D printing.
Thank you, John, sir, for this opportunity. I'll be talking about the magic of 3D printing in ophthalmology. So, what is 3D printing? So, basically, it is a technology where we can build something really physical, like a physical object with a digital file. So, you can design something in your laptop and then get it actually developed physically. You will get it as a physical object. So, what are the processes involved in this? So, one thing is the designing. So, using CAD software or a scanner, you can actually design a model which you want, and then that will be sent to the 3D printing machine, which will go for the slicing, and then it will start printing. So, printing happens into different methods, which I'll talk about. Then is a post printing process, and then the final product. So there are different materials in the market which you can get, with which you can 3D print. So one is the polylactic acid, the other one is ABS nylon. So most of the prototypes can be done in PLA or ABS, because PLA is a little brittle, so we can actually use ABS, but for prototyping it is good. So once you are done with the prototyping, if you want to get for the final product, you can make another thing with a stainless steel or a resin. So resin is a little foldable, so the flexible also. So these are different materials used. So there are two methods by which you can 3D print. So one is the extrusion material and the other one is sintering. So extrusion, it is like printing a 2D image. It's like a single sheet of paper. So when we keep a lot of paper together, it becomes thick, right? So that is the exactly the way that this is going to print. It will print in 2D, one on the other. So it will make the whole product. And sintering is such that we have the powder in whichever material required, and the laser will actually deliver a little bit of heat, which will not be so much that it will melt those powder, but at least just to join the powders together to get a proper model of the design which you want. So different materials can be used, like SLA for model for prototyping, FDM for prototyping, inkjet are used for bioprinting, SLS for metal instruments. So nowadays it's all there everywhere. In education, we are doing 3D printing in aircraft, construction, design, manufacturing, and medical. And 3D printing actually, the children are able to understand this much better, and they are able to even make new designs of their own in their early age, and because they become inventors in the future too. So nowadays, people are using 3D to design the architecture of buildings. And recently, we have seen 3D printing a house being constructed in India. Also, the aviation department has, the automobile department has 3D printing done in their engines, and even the food industry has started 3D printing these their food. Even and NASA is also planning to take 3D printers along with them to their space missions, so that they can print all these instruments right there in wherever they are. And in health sector, we can see 3D printing has come into dental, where they use these 3D printed dentatures. So while taking consideration of medically, so it was actually introduced in 1990 by Mankiewicz in University of California, but it didn't take much of uh, and by 2013 is what the 3D printing started getting a little more popular. So going directly to 3D printing in ophthalmology, these are all the places where we are able to 3D print structures, and we have a article by Dr. John in KGO. So where all we have used this? We have used this to make smartphone adapters, and Dr. Ahmed Ataya, he is also a good friend of Dr. John's, who has actually made this. There are fundus photography devices which can be 3D printed easily, and it would only cost you around 200 to 300 bucks to make this in the 3D printed laboratory. And we also have a foldable red cam which is done by Dr. John. So this basically folds into a box. So it is so easy to carry. You don't really have to carry the old big tube like structures nowadays. You just have to fold it and you can keep it in your pocket. You can just take it all around and take images of the fundus, and it's going to be available in the market soon. So he's doing the final prototype of this. So like you can see, these are the images taken by that. These are the images taken from the uh, jaundice fundoscope, and we have 3D printed slit lamp microscope, which actually increases the zoom. Also, we have wet lab surgical models which are being used. We have so this is all used for training, and there are 3D printed models for planning radiations, even 3D printed model of OCT, which has been 3D printed to make the patient understand what he is going through in real time model. And also instruments are being developed for with the same 3D printing, and pupil expander link like Canabrava also used 3D printing technology to print his pupil dilator, and a lot of other things present in 3D printing for us. But I would like, see, there are also spectacles and lenses being developed by 3D printing. But want of time, I'm just skipping through it. So basically, we can, the best part of this is we can actually start 3D printing ourselves by using a website called the Tinkercad. So these are all the 3D printed objects, and here is a website where we can actually 3D print by ourselves. You just have to go to Tinkercad, and you can see there there is a small tutorial also, and it is very simple, very easy. Even kids are doing their projects over here. So Tinkercad allows you to uh, use their software real time in the website itself online. You can design your whatever you want to, and then get the file and get it printed from a 3D printed shop. It is available. It's like a normal Xerox shop we have 3D printing shop as well. You just have to give them the file and they will 3D print the whole. So easy. You can do it with your laptop also. uh, and this is one thing which I want to stress, and learning this skill will actually help us think about new things, innovate and invent new things. And there is another website, Thingiverse, where you actually get a lot of these 3D printed printing model design already present there, which you can download and just give it to the 3D printing vendor who will actually deliver you the objects. So you can see over here, these are all the uh, documents that you get. You can just download it. Even there are a lot of models for medical ophthalmology, medical also, like the skull. And also you can see there are things for ophthalmology like the lens guard for breath guard. There are vernier calipers, occluders, 90D to 78D protecting boxes, etc. So these are my innovations on 3D. This is the slit scope which I have designed. It's just with the torch, it's just 350 rupees. And the best part is with the ASP, which is a magnifying device, we are able to take these kind of images and videos without a slit lamp. There is no slit lamp involved in this, and it gives exactly the quality of image that you take in slit lamp. Also, this is the gimbal scope. Basically, this is the one we use to record. This is the first time we are actually presenting in all India also. A very novel way of recording retinoscopy reflexes, which were not been possible before. This is the adapter which we have 3D printed, and this is the reflexes which we could see with the 3D printed adapter. So these kind of things were not done before, but now we are able to do this because of 3D printer and the designing. It's the neutralization, and you can see how beautifully you can see the scissor reflex too. Thank you.